So what we're doing today is we're still working with polynomial functions. This whole chapter will be dealing with polynomial functions. But the first thing we're going to be looking at is addition. Adding polynomial functions or polynomial expressions vertically. Up and down, vertically. Can we add them vertically? Really, we're just lining them up. I'm going to put one over the other, and we're going to put like terms. We're going to match like terms out. So our first one here is 3x cubed plus 2x squared minus x minus 7. That's the first one. The other one is x cubed minus 10x squared. Well, what's our next number? Plus 8, isn't it? Do I have a term with x? Well, no, right? The second one doesn't have, there's no term with x in here. So I won't put anything under the minus x. I'm just going to do plus 8. I'm just lining them up. So when we do it vertically, we line up the like terms. And I leave a space if there's not a term there. Since there's not a term for x to the first power, I'm just going to leave it blank. I'm not going to put anything in there. Now, what did it tell us to do? It told us to add. 3x cubed plus x cubed is 4x cubed. 2x squared plus negative 10x squared is negative 8x squared. Well, negative x plus, well, we don't have anything here, so it's just negative x. And negative 7 plus 8 would be That's it. That's it. Yeah. Yeah. We just line them up and add them, because when we add them, we're just combining like terms. So we can add them vertically, like this here. Are there any questions on this here? Now we could also add them horizontally, in a horizontal format. Now the difference for this here is we're going to put parentheses around both expressions. And we're adding, so I'm going to do plus. So we can do it horizontally. And it's going to look a little different, but the process that we're doing and what we're doing to add these two together isn't going to change, because we're still going to add like terms. We're just not lining them up. Now, since it's addition, we can just drop the parentheses, because addition's not going to change any signs. I mean, realistically, this plus minus 5, you can just write it as minus 5y. You don't have to put the plus negative 5y squared. And again, we can just drop these parentheses, because positive 1 is not going to change the sign. A positive and a negative is going to be a negative. Positive is positive. The only way that we would really change anything is if that was, instead of having an addition, where instead of adding these two, we would be subtracting. If we were subtracting, then it would change some signs, and we'll see that here in a minute. Any questions on this so far? Now, what I'm going to do next, you don't have to do this every single time. I'm going to do it just so we can kind of see it and how it works. But what I'm going to do is I'm going to reorder this so that like terms are next to each other. Well, 9y cubed, there's no other terms with y to the third. Well, our next one here is 3y squared. Well, 3y squared and negative 5y squared, they're like terms, yes? So I'm going to move it over and say 3y squared minus 5y squared. Then we have 2y, and its like term is 1y plus y. And then we have plus 1 and negative 4. So I just rewrote it so the like terms are next to each other. I just rewrote it so the like terms are next to each other. And now we can combine them. see here. There we go. So 9y cubed, because there's no other y cubed like terms for it. But 3y squared minus 5y squared would be minus 2y squared. Then we also have negative 2y plus y, which would be negative y. And 1 minus 4 would be minus and that's it. Questions on this here? Bless you. Any questions on this here? Now, you don't have to do this middle step here. If you can go from this to this just fine, and keeping the numbers and just combining them, that's fine. You don't have to rewrite it. Because if you can see from this one here that 3y squared minus 5y squared will give us negative 2y squared, and just go to that step, that's fine. And you can see that negative 2y plus y will give us negative y. That's fine. You can go from one to the other. You don't have to rewrite it. Any questions on this here so far? Any questions on anything we've done so far? We good? We ready for another one? So let's look at this here. 2x cubed plus x squared minus 3x plus 4 and x cubed plus 7x squared minus 2. We want to add these together. I'm going to start off just by writing 2x cubed plus x squared minus 3x plus 4. And we're going to add to it x cubed plus 7x squared minus 2. Because again, they didn't give us a term with x, so I'm not going to put one there. And the reason I avoid putting one there is just so that I don't add something that's not a like term, that's not together. Because if I write it like this here, with the negative 2 underneath the negative 3x, if I'm not paying attention, there's a chance I will combine those two terms. So I like to line everything up according to what we have. And then what are we going to do? We're going to add. Well, 2x cubed plus x cubed is 3x cubed. X squared plus 7x squared is plus 8x squared. Well, negative 3x is just going to come down because we don't have anything that we're adding it to. There's nothing being added to it, so it doesn't change. And lastly, 4 plus negative 2 is going to be plus 2. And that's it for this here. Any questions on this here? Any questions on anything we've done so far? How do we feel with addition? We're good with addition? Because it really doesn't matter if we do it vertically or horizontally. It's doing the same thing. And I'm not going to restrict you to adding, especially on the test. You have to do these horizontally, you have to do these vertically. You can pick which one you do.
It seems like the vertical is a whole lot easier. Is there ever like a time the horizontal format is easier?
We'll do horizontal when we're solving, because if we're trying to solve for something, we normally leave it horizontal. But you can switch between the two. Because there's times when I'm solving or multiplying things together, I will go to the horizontal just so it lines up better. And then I'll set it equal to and continue solving. Because it's all personal preference. Some of the times when you do it vertically, you're going to need to do it off to the side or know that this is a part of the same step. But it's all personal preference. So let's look at this one here. Now, subtraction's not going to be too much different, especially vertically. So I'll start off with this here, and then we're going to put the other equation below it. Now this one here, order matters a little bit because subtraction, it matters which order we subtract. So it's saying to subtract 2x cubed plus 6x squared minus x plus 1 from this here. So they've told us the order. And we're going to subtract. Now on this one here, I would write the subtraction sign all the way across in front of kind of each pair like this here, because this is kind of giving us a reminder of what we're doing. It's reminding us that we're subtracting for each and every single one of them. So that when we subtract, well, the first one's not too bad. 2x cubed minus 8x squared. 2 minus 8 would be x cubed. Okay, that wasn't too bad. But again, some of these, they get pretty long, and if we're not paying attention, we'll start adding if we're not paying attention. So I rewrite the subtraction as we go all the way through. Now this next one here is 6x squared minus negative 3x squared. Well, a negative and a negative make a positive, so I can change it right there. 6x squared plus 3x squared is plus 9x squared. Two down. The next one is negative x minus negative 2x. Well, the negative and negative would make a positive again. So negative x plus 2x would be plus x. And lastly, 1 minus 9 would be and that's it. That's all we'd have to do for this here. Now, this isn't much different than addition, except for the fact that we're subtracting instead of adding. The process is almost the exact same. We're just subtracting each number instead of combining or adding them. But how we set up and how we went from one step to the next using subtraction doesn't change too much. But that's it. Questions on this here? We good with this here? Okay. Now we're going to look at horizontally. Now the setup is the same. We'll do 3z squared plus z minus 4. And we're subtracting from it 2z squared plus 3z. Now if you're doing this horizontally, I would highly, highly, highly suggest using the parentheses, putting parentheses around it. Because this negative here is going to affect the signs of both of these here. Because we're subtracting it. We're subtracting it. Essentially, we're going to have to multiply through by a negative 1 for our 2z squared and 3z to get their real sign. Now, for the first one, 3z squared plus z minus 4. There's no real change to that. But now 2z squared is not positive anymore. It's negative. Because of our subtracting, we're subtracting a positive, which is just the same as saying it's negative. The same with 3z. It's now going to be minus 3z. And for subtracting, it's changing the sign. It's changing the sign in front of the number. Well, at this point here, we can move it around. I would move it around and put the like terms next to each other. Well, 3z squared's like term is negative 2z squared. Plus z minus 3z minus 4. I just rearranged it so the like terms are next to each other. Any questions on any of this here so far? Any questions on any of this here so far? What is 3z squared minus 2z squared? Because these here are our like terms. Z minus 3z would be minus 2z, and then we just have our minus 4. And that's it. That is all we have to do for this here. Any questions on any of this here? So what do we think about subtraction? You feel good with subtraction? If I gave you problems to solve, you could solve them if we were doing addition and subtraction? Yes? So good? Okay. If we're good with addition and subtraction, that's fine. We'll move on. Because if we don't need to see more examples of this, that's fine. This here looks like it'd be different. Find sum or difference. This here is really the exact same thing, except they already set it up for you, didn't they? So we just have to solve it. We just have to simplify it. So this isn't any different. We're just adding like terms. Because here it's just saying that 2x squared minus 6x plus 5 plus 7x squared minus x minus 9. Because we're adding, the sign's not changing, so I don't have to worry about that. Because if it was subtraction, then we would. Well, 2x squared plus 7x squared is 2 plus 7 gives us 9. Negative 6 minus 1 gives us negative 7x. 5 minus 9 would be minus . That's it. So we do the same thing with subtraction. So this isn't any different than the ones we've done already with addition and subtraction, except for the fact that they kind of already wrote it out for us. Questions on this here? Are we good with this here? Yes. We like addition and subtraction so far. This chapter is easier than the last one. Multiplication. Multiplication. I'm not going to delve too much into vertical form of multiplication. We're going to do mainly just horizontal. Because our horizontal multiplication is just going to be negative x squared plus 2x plus 4 times x minus 3. What would we do to multiply these here? What would we do to multiply these here? Have y'all ever multiplied something like this before? We'll start with x squared, and we're going to multiply. Distributive property. We did this with polynomials where we multiplied through. We're going to do negative x squared times x, which is going to be negative x to the third, because when bases are the same, we add the exponents. So x squared times x would give us x to the third. Negative x squared times negative 3. A negative and a negative would make a positive, and we would have 3x squared. Any questions on this here? Hopefully this should look similar because you've done this before with binomials, two terms where we multiplied through using FOIL, first, outer, inner, last. We're doing a similar process. Any questions on how we got the first two terms? Well, now we're going to do it with the next one, with 2x. Well, 2x times x is going to be plus 2x squared. 2x times negative 3 will be negative 6x. Any questions on any of this here so far? We'll move on to the last one. It's going to be 4 times x, which is going to be plus 4x. And 4 times negative 3 will be negative 12. Any questions on anything we've done so far? Are we good with all this here? Yes? Well, we're almost done. We still need to combine like terms, because we do have some like terms. Negative x cubed doesn't have any like terms. But 3x squared plus 2x squared will give me plus 5x squared. 3 plus 2 would give us 5. Negative 6x plus 4x would give us negative 2x. And then lastly, we have minus 12. So with these here, we use the distributive property to multiply through and then combine like terms. And that's it. That's all we have to do for this here. Any questions on this here? Any questions on any of this here so far? We good with this here? Yes. Well, let's do it again. Let's see another one. Y plus 5 times 3y squared minus 2y plus 2. So we're going to multiply these two here together. We're going to multiply these together. So the first one I'm going to start off with is the y. We're going to start by multiplying with the y first. So when I multiply through with the y, we're going to use our distributive property. So y times 3y squared, and then y times negative 2y, and y times 2. Well, y times 3y squared is going to be 3y cubed, because y times y squared would give us y to the third. And then we'll do the next one, y times negative 2y, which is going to be negative 2y squared. And y times 2 is going to be plus 2y. So we're just multiplying through with that y. We're distributing it. We'll do the same thing with 5. We're going to distribute through all three terms. Well, 5 times 3y squared is going to be plus 15y squared. 5 times negative 2y is going to be minus 10y. And 5 times 2 is going to be plus 10. Any questions on this here so far? Now we're going to combine like terms. I'll rewrite it so the like terms are next to each other. Well, 3y squared doesn't have any like terms. Then we have minus 2y squared. Well, it's like terms with 15y squared. So I'm going to put those next to each other. Plus 2y minus 10y. Those are like terms, and then we have plus 10. So I'm just moving the like terms so that they are next to each other, so that we can see how they combine. Well, 3y squared or y cubed doesn't change because it has no like terms. Now, negative 2y squared plus 15y squared is going to be plus 13y squared, because those two are like terms and we can combine like terms. And we also have 2y minus 10y, and 2y minus 10y would be minus 8y. And lastly, we have plus 10 because it doesn't have any like terms. And that is it. That's all we have to do with this one here. Any questions on this here? Any questions on any of this here so far? Are we good with this here? Yes? Okay. Do we want to see another example of multiplication? We're good? We go with multiplication? Because we can see, I can show you one more.
Yeah. Or you can go through it afterwards.
Well, the next one we have is actually multiplication again. It's just in a little bit different form. We can multiply more than one thing together. It doesn't have to be just one of these binomial, these two-term polynomials. Now, when we do this here, I'm just going to do the first two here. I'm going to multiply these two together. Now, you'll need to put parentheses around it because, again, it's still going to be multiplied. After we finish multiplying x minus 1 and x plus 4, we're going to have to multiply it with x plus 5. So when we do this here, x times x gives me x squared. X times 4 would be plus 4x. And then we do the other two. Negative 1 times x will be negative x. And negative 1 times 4 would be negative 4. Any questions on this here? Because y'all have done these before, yes? These two terms. Now we can combine like terms. Well, 4x minus x is going to be plus 3x minus 4. Now we're going to do the same thing again. We're going to distribute through. We're going to do x squared times x, which is x to the third, because x squared times x would be x to the third. Now x squared times 5 would be plus 5x squared. So that's what we get with multiplying through by x squared. Now we've got to do 3x next. Well, 3x times x is going to be plus 3x squared. 3x times 5 is going to be plus 15x. And lastly, we're going to do the same thing with negative 4. Well, negative 4 times x is going to be negative 4x. And negative 4 times 5 is going to be negative 20. Any questions on this here? And then last but not least, we've got to combine like terms. And it worked out that this here, when we multiplied it, the like terms are already next to each other. So that's kind of convenient. X cubed doesn't have any like terms, but 5x squared and 3x squared is plus 8x squared. 14x or 15x minus 4 is going to be plus 11x, and then we would have our minus 20. And that's it. That's all we'd have to do for this here. Questions on this here? Questions on any of this here? Are we good with this here? Yes? Not too bad? Okay. Let's see here. How about this one here? What do you think? This is going to be a little bit more challenging? So this one here would be a little bit more challenging, wouldn't it? Let me see here. Okay. Okay, yep, that's what I thought. So this one here would be a little bit more challenging, yes? Because what is this saying? It's saying that we have x plus 1 times x plus 1 times x plus 1 times, and we'd have to multiply it by itself 5 times, yes? And just so you know, I did write down these numbers on this sheet, but that's not multiplied, right? I didn't do any of the multiplication here. This here, it actually works out if we multiply it, it's going to be x to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared this right here. And it works out this way anytime. Because we could say to the 6th power is going to be x to the 6th plus 6x to the 5th plus 15x to the 4th plus 20x cubed plus 15x squared plus 6x plus 1. Multiplying it by itself 6 times. Now, I'm not getting these numbers just out of nowhere. It is this here. This is Pascal's triangle. And it works out because I chose 1 and 1 for A and B. These numbers right here for the 5th power will be the numbers that go in front of x, and x is decreasing. So this here is a quick way to multiply something by itself however many times. So you can actually extend it out farther and farther, and it'll tell you kind of what the leading coefficients are going to be. It works for positive and negatives. So sometimes when we hit higher powers, Pascal's triangle actually works out quite well. And after Thanksgiving break, I'm going to pull a Pascal's triangle Christmas tree out. So if you had me last year, I had it, I think, hung on the door somewhere. It looked like a little tree. That's what this is. That's what it is. I made a Pascal's triangle Christmas tree with that, and that's just really multiplying these by themselves. Now, there's one other thing I want to look at, and it's not so much that it's going to change how we multiply things, but they have these certain factors, like the sum and difference, so the difference of perfect squares. So looking at this here, 4n plus 5 times 4n minus 5, that's a difference of perfect squares. We covered that with factoring, yes? Because we saw the difference of perfect squares. If I have two numbers that are perfect squares with subtraction in the middle, we can break them down like this here, yes? Well, it works out that if I wanted to multiply, it's really this first number squared minus this number squared. Because 4n squared would be 16n squared. 5 squared would be 25. It works out that it's going to be this here. Now, do we have to do it that way? No. Because if I multiply through, 4n times 4n will give me 16n squared. 4n times negative 5 will be negative 20n. 5 times 4n will be plus 20n. And 5 times negative 5 will be negative 25. Well, negative 20 plus 20 will cancel, leaving me with this here. So if we notice that it's a difference of perfect squares, we can kind of jump to 16n squared minus 25. Or if we just multiply it out, we will get the exact same thing. Any questions on this here? Now, the last one we're going to look at is this one here. So if I rewrote this out, it would be 9y minus 2 times y. Because whenever we have that exponent, it's just telling us that we're going to multiply this thing by itself this many times. Since it's to the second power, we're going to multiply it by itself twice. AB plus 4 to the third tells me that I'm going to multiply it by itself 3 times. So here we're just doing it once, and we can distribute. So 9y times 9y Well, 9 times 9 is 81. Y times y is y squared. 9y times negative 2 would be negative 18y. Negative 2 times 9y will be negative 18y. And negative 2 times negative 2 would be plus 4. Combine like terms and we get negative 36y. And we have this thing here. Any questions on any of this here? Any questions on anything we've done so far? We good with this here? All right.